Hello, welcome back for lesson 3.2. In this lesson, there are other videos, just like there were for 3.1. This is just an extension video, so I would prefer that you are watching the other ones first on how to calculate slope, because these are a couple extension problems is all I'm doing today. 51 and 54 in your book. So let's go ahead and get there. So 51 is about solar energy. It says the graph below shows the annual shipments of solar thermal collectors in the United States. Using the graph below, find the slope of the line connecting the first point and the last point, and then explain in words what the slope represents. So it looks like that from the first point to the last point, it does increase because we always read a graph from left to right. And we have to take notice that our X values are the years. It doesn't give us a base year, but it just says the number of years gone by. And then the Y values are a number of shipments. So I wrote my points in coordinate form here, 1 and 8,000 and 10 and 20,000. And I reminded myself that the X values are the years and the Y values are the number of shipments. And then I'm going to remind myself that slope is the change in Y over the change in X. And you'll see in my other videos that I label these X1 and Y1 and X2 and Y2. And it doesn't matter which one you name which. It's just that you're consistent from one to the other, because we are going to take the difference in our Y values in the numerator. So I'm going to start with 20,000 and subtract 8,000. So I get a difference of 12,000. So the number of shipments increased by 12,000. And then that means I'm going to take the difference in my X values. And because I started with Y2, I have to start with X2. So this is going to be X2 minus X1. So that's 10 minus 1. So that's 9. So the number of shipments increased 120,000 shipments over 9 years. Okay, but we want to know what the slope is, and the slope is a per unit rate of change. So we're going to take 120,000 and divide that by 9, and we get, 20,000. So we get about 13,333.3 per one. So you can only have a whole shipment. You can't have part of a shipment. So for this one, I'm going to round to the nearest whole shipment. So this tells us that each year, the number of shipments is increasing by, and I'm going to say approximately, because this is a little bit of a rounded number, we decided, approximately 13,333. Okay, a couple of things that are important here. One is, this should have been each year. Each year is an important thing. It tells me what my denominator is doing, because these are years. This is years in the X's. So each year means I'm increasing the years by 1. And as I'm increasing the years by 1, I'm increasing, it says, and that's because my numerator is positive. So I'm going to use the word increasing. And it says by approximately, because we rounded, and then my value in the Y, which would be my number of shipments. So it's important that you're talking about, in the description, you're talking about both pieces, the value in your numerator and its variable, which is the number of shipments, and the value in the denominator and its variable, which is years. So each year, the number of shipments is increasing by approximately 13,333. So math is not just about doing the numbers, it's about being able to explain the context of what we're discussing. So I would like to look at number 54 together on page 228. So number 54 is all about horse racing. It says the graph shows the amount of money bet on horse racing from 1990 to 2015. Use the chart to work the following problems involving slope. So it's kind of hard to read just because of the picture. So my base year is 1990. And in 1990, there were 34.4 $million in betting. Okay, so this is millions of dollars along here. I'm having a hard time reading that. And then it looks like the number of dollars that are being bet on horses is going up by quite a bit. So it was 34.4 in 1990, and in 2010, there's $138 million being bet in horse racing. Wow. So let's write what X and Y are in words. That's important to establish. So X is years, and then we have millions of dollars. Okay. So A says find the slope of the line from 1990 to 1995 and explain in words. Okay. So 1990, let's write these coordinates. So 1990, we said they were 34.4, and we'll worry about the millions later because they're all in the same unit. We don't have to worry about the units until the end. And the other point is 1995, and in 1995, there were 44.8. So it increased a little bit. So the slope is going to be the change in the dollars spent, right? The dollars betting versus the change. This symbol here is a delta symbol. In Greek letters, delta symbol for change or difference. So the difference in the amount being bet over the difference in years. It's always good to write out what variables are we working with in words. Okay, so we're going to do, I'm going to start with 44. Like I said, it doesn't matter which one you start with as long as you're consistent. 44.8 minus 34.4 over, so since I started with the 44.8, I had to start with the 1995. So 1995 minus 1990. I'm going to get out our calculator, and 44.8 minus 34.4 is 10.4, and 1995 minus 1990 is 5. And then we're going to take 10.4 and divide by 5, and we get 2.08 over 1. Okay, so here's another way that we can write this slope, which is a little bit more of a strategy that you can use every time. So we can say for every, and I'm going to write it in general, and I'm going to write it for this one. So for every 1 increase in the X variable, we expect the Y variable to, and then you're going to decide whether it's positive or negative. You're going to say increase or decrease by, and then you're always going to say approximately, because it's always a rounded value, approximately whatever your slope is, the slope value. Okay. So these are the things that you're going to have to fill in right here. Everything else you can write exactly like this. For every one increase in the x variable, we expect the y variable to, your choice of words, increase or decrease. If the slope is positive, you're going to use the word increase. If the slope is negative, you're going to use the word decrease. And then by approximately, and then your value of slope goes in there. So let's write it for this one. So for every one, and the reason we're using 1 is because our slope is a unit rate over 1. So for every one increase in my x variables years, and I'm going to say since 1990 because that's my base year. Years since 1990, we expect the money spent on horse racing to increase, and I used increase because our slope was positive, by approximately 2.8, I'm going to use my dollar symbol, $2.08 million. So I've got my dollar symbol in the millions. So let me highlight for you all of the things that you should be adding in your own context. So the x variable, the y variable, the increase or decrease, and then the value of slope. And this is where I did that. Years is my x variable. Money spent on racing is my y variable. And we were an increase, and my slope was a 2.08. And I had, make sure you've got your units for each in your description. Okay. And the other video should help you with some of the finding your slope and some practice with some other slope calculations. Catch me back for lesson 3.3.